Welcome to Securing Multi-Tier Modern Application Architecture. This is a quick demo on Voltstack Secret Management. Applications frequently require secret to talk to each other. For example, in the case of a microservice talking to a database, it needs a secret such as a username or password to access the database. Presently, many applications store secret in the clear, in code or in configurations. This practice was tolerated when the microservice and database were in the private data center behind a firewall, and the source code and configurations were also very tightly controlled. But when applications are distributed to the edge, whereas the edge gateway is not under the application owner control, this secret could be compromised. Please refer to Volterra official documentations and literature for details on secret management. Here, just an overview on how it works. Before we get into the demo, here are a few things that is important to understand. Volterra's secret management consists of two main components. One is what we call a blindfold, and the other one is a wingman. Blindfold is a cryptographic encryption, and you can blindfold your clear text with either using the VASCTL, or you can use the Vault console to encrypt or to blindfold your secret. So in order to blindfold the clear text, you require a policy ID and the Volterra public key. And all these things you can automate it using your CI/CD pipeline. The other component I mentioned is the Wingman. This Wingman is basically a security sidecar auto-injected into the pod or into the application whenever you deploy the application in Voltstack. So what the Wingman does is that it provides the identity bootstrapping of the pod when you spin up your application. It actually does the secret management as well as the external secret management, the key management, and the certificate rotations. So for details, please refer to the official documentations on the details on blindfold and Wingman. Alright, so here this is a quick overview on how the process of this secret management will looks like. The first thing that you need to do is you create a secret policy. This secret policy basically is a policy definitions that you want to see, a policy contract that you want to specify who can read or who can get the clear text or who can't, or in what kind of circumstances that the clear text can be read. You need a public key, and this public key is a tenant-specific public key to encrypt the clear text. This is not the user public key; it's a tenant-specific. So with these two perimeter, you use it to encrypt. So basically, you use you have your clear text, you blindfold it, and from this blindfold, you got an encrypted type of nouns, encrypted text, and this encrypted secret you can actually bundle together with your image, and in fact you can put it together in your image. In my demo later on, I'm going to put this encrypted secret as part of the config map so that my application can read it from the config map. So when you deploy this application in the application registry, so what happens is that whenever you spin up the application, this application will have the encrypted secret, and a Wingman sidecar will be automatically injected into the application. So in this application, there will be the two containers. One is the application containers, and the other one is a Wingman. So in order for these applications to read the clear text, what this application need to do is that you need to send an API to the Wingman. Later on, I'm going to show you how does it looks like. And what happens is that this Wingman will blindfold the encrypted secret. This is the encrypted secret, and it creates a blindfolded type of text, and then it will talk to the Volterra centralized control plane. So what happens is that once it reaches this centralized control plane, Wingman have all the authority with all the secret, with all the certificate that it able to talk to it. And what happens is that the tenant-specific private key will be used to turn this encrypted blindfold into another blindfolded object with an encrypted secret. So what happens is that basically this is an E with a purple. So once it reached the Volterra control plane, this E purple become C purple. The content is still blindfolded. The whole message is still blindfolded, except that the blindfolded embedded inside with the secret clear text. So no one still be nobody able to read it, including Volterra ourselves. So in the Volterra, we won't be able to see the C. We only potentially only can see the C with the purple, which is the blindfolded. And this blindfolded clear text or unencrypted secret will be sent back to the Wingman. And because Wingman are the one who blindfolded, Wingman now have the ability to unblindfold it to read the clear text, and this clear text will be sent back to the application. And this clear text can be cached. It will be cached in the memory, and you can say that whether you want to cache for how long, the timestamp, and when the cache expire, it will talk to the Volterra control planes to retrieve it again. So this is in the gist of how the flow. So what happens is that this C will never leave the applications, because anything that went out or go out from this port either is an encrypted or is a blindfolded type of text. Now let me show you how all these things works. Currently I have an application, and this application is written. Let me show you the application. I have two applications. In fact, they are the same applications that is written. This is my apps, my secret apps. This application, if I show you the apps, this is basically it's a Node.js application. You can see that the key part here is that it does actually do a request.post, actually do a HTTP post to this localhost :8070 secret unseal. This port is actually listening on the Wingman. The Wingman basically receive. You have to send this API to the Wingman. This is the API endpoint on the Wingman. Once Wingman receive the post input is in the form of a JSON. So what I had as an example, this is an example JSON. The string, and then all this is the blindfolded text. If I show you, this is a blindfolded text. So what happened here is that the program will read the blindfolded text, post it to Wingman via this API, and what happens is that Wingman will talk to the Volterra centralized control plane, and then to grab the clear text. Then what happened, this is basically the application, and will display. So basically what I'm trying to do for this application is that this application require to talk to the AWS API server, or you need to retrieve some critical information from the AWS API AWS systems. So what happened is that it require the API key and the secret in order to communicate, to send an API to the AWS. So what happened is that this input.json, this encrypted string, a blindfolded string, consists of the information required to talk to the API, to talk to the AWS API. So I have two sample application here. One is called my top secret, and then the other one is actually the same. Actually, it's the same. My top secret.dev. If you look at the apps, this is a blindfold.apps. Basically, this is the applications that got basically this one. Push it to the app registry, so it will be deployed. So the reason why there are two here, because what happens is that I have two environments. One is the production environment. One is the development environment. So both of them will having exactly the same apps, but of course with a different label here. So this application currently are deployed into the Voltstack. Before that, let me sign in to the Volterra. While waiting for that one, as I mentioned, these applications are currently deployed using the Argo CD to deploy into the top secret prod and top secret dev. The prod is actually on Voltstack number 2, and then the development is actually on Voltstack number 4. So that's why here you can see that one is in Voltstack 2 prod, and then the other one is dev. development environment. So currently these two are running there. Okay, let's see. What happened is that in the secret policy, I have created a very simple secret policy. Remember that we need to have a secret policy. This secret policy basically is a definition, is a contract that you written to say that who can retrieve the secret. So what I had here is, let's say if I go to the secret policy, I have created a secret policy called Foops Secret Apps Sec Policy, and in this sec policy, I have this policy rule. So and then the action is allowed. So what I mean is that if I show you this secret policy rule, I believe it's this one, you can see that I have put some perimeter in there to say that the expression, the client selector expression, say that if the apps equals to top secret dash prod, then the action is allowed. So what I mean is that if I'm coming from the right application, although that got deployed exactly the same application got deployed, what happened is that only the production port able to retrieve the blindfold. So once basically these applications are deployed into the Voltstack, as I mentioned, and I have the application got exposed. I got two. One is top secret.vault, and the other one is called top secret.dev. So these two is exactly the same apps as I mentioned, except that they are deployed in a different environment. So for the one in production, if I say show my blindfolded API secret, you can see that I managed to get from this string, the config map. What happens is I decided to put in the config map so that I can change the string anytime as I want, rather than hard code it into the program. So from this string, it derived the SS key ID as well as the secret key ID. So now with these two information, I can use my program, the program written. I can use this SS key and the secret to talk to the AWS API to retrieve, to do operations that I want. Whereas for this one, this is a development environment. Although that the application are exactly the same, they are using the same config map. This application does not have the appropriate permission to retrieve. So hence that's why you can see basically just a garbage. Whereas for this one, I can get the SS key. So hence that's why, although that in fact this application are with all this blindfolded secret actually is in GitHub or in my GitLab, it is alright to push it up to the GitHub or GitLab, because these informations are not in clear text, and only the application port have access to the key, to the clear text. Not even Volterra themselves, or Volterra's SRE, they won't be able to see it, because there's only the application within here can see the clear text. For further information on the secret management, please do, I encourage you to look into the secret management documentations, the details. And this is just basically a quick overview on how you can leverage on the secret management within the Voltstack. That is to ensure that your clear text never leave the apps. So the clear text is always maintained in a secret form in the whole chain. Thank you for watching.